All right, so I've just written out our equation for q prime and substituted in the definitions that we think are true, what the new q prime is in terms of the old q, and what the new rewards are in terms of the old rewards. And so if this works, if we can do a bunch of if and only ifs that actually bring us to something that we know is true, then we should be good.
Okay.
So, all right, how can we do have an equation for q. We don't have an equation for q minus psi of s, but maybe we can cancel some things.
Oh, I can see two things we can cancel.
All right.
Okay, so the first psi of s on the left side of the equal sign,
Yep.
that matches up with the first psi of s right next to r. Yes, right there.
Yeah, because we're summing this over all next states, all next s primes, and this sums up to 1. It's a convex combination.
Right. So that means effectively you could take it out. It doesn't depend on s prime anyway, and they go away. Good. So now we got q of sa on one side, and then you can actually handle the next one. If you look at the next psi of s prime, the gamma of psi of s prime, well, that matches with the minus gamma of s prime inside the max because that max is multiplied by gamma.
Good. Right. Right. Yeah. So it's interesting. And the max itself is not impacted by this quantity because it doesn't depend on a prime.
Right. It is in fact a constant.
So we can actually take out this constant, and it actually cancels this one. And look what we're left with.
The original equation.
Ta-da! We're left with the original Q equation, which we know is true. And so this is true if and only if the original thing is true. This is an actual solution to the Q equation, the Bellman equation. And so, right, this is what happens to the Q function. It's the old Q function shifted down by the potential function.
Right. And at no point do we divide by 0, so everything is great.
Right, and how do we know that we still have the same policy, the same optimal policy?
In which case?
So we know we have some optimal policy for this Q function. This new Q function, Q prime, has an optimal policy. How do we know it's the same?
Well, because it's just the original Q function, and you're just being shifted around by a constant, and so it doesn't change the max, and therefore it doesn't change the optimal policy.
Exactly. Awesome. All right, so this now gives us 3 total different ways of messing around with rewards to give us new Q functions that don't actually change the policy.
That's really nice. So I have a question.
Sure.
You didn't write anything down here about any restrictions on the potential function.
That's right.
Does there have to be any restrictions on the potential functions? Maybe potential restrictions, potentially?
I'm going to say no, because it's all going to end up being okay and canceling out. So there's a sense in which you actually not changed anything by throwing in one of these additional potential functions, but maybe it can help us learn faster. So let's look at an example where this might matter.
Okay.